Hi everyone. In this video you're going to learn how to balance combustion reactions. Combustion reactions involve what's called a hydrocarbon, which is some sort of fuel that contains carbon and hydrogen, sometimes oxygen. And you're going to burn that in the presence of oxygen to produce carbon dioxide and water. When you have a combustion reaction, you're always going to start with balancing your carbons first, the hydrogens second, and the oxygens third. In some cases, you may end up with a coefficient that is a fraction. We cannot have coefficients that are fractions, so you may end up having to multiply by 2 or 4 or some other factor to eliminate that fraction. So let's start with the combustion of CH4. On this side we have one carbon. We're going to do carbon first. And we have one carbon over here. They're balanced. Next we're going to do the hydrogens. We have 4 hydrogen. And in order to get 4 hydrogens on the other side, we're going to put a 2 in front of the water. Now let's see how many total oxygens we have on the product side. We have 2 oxygens here, and a total of 2 oxygens here, for a total of 4. We have only one other place where we can actually put a coefficient to balance this equation, and that's in front of the O2. So to make our oxygens balance, that is going to need to be a 2. So our coefficients are 1, 2, 1, 2. In the next one, we have 3 carbons. So let's put a 3 outside of the CO2. We have 8 hydrogens. So let's put a 4 outside of the H2O. Then we're going to figure out how many total oxygens we have on the product side. We have 6 and another 4 for a total of 10. The last place that we can put a coefficient is in front of the O2. That will need to be a 5 to give us 10 oxygens, so our coefficients are 1, 5, 3, 4. In the next one, the combustion of C8H18, we have 8 carbons, so let's put 8 carbons here. We have 18 hydrogens, so in front of the water, we're going to put a 9. Now let's see how many oxygens we have. That gives us a total of 16 plus 9 equals 25. Again, we have one other place we can still balance, and that's in front of the O2. Now to start with, half of 25 is 12.5, and that does give us 25 oxygens. However, we cannot leave that 12.5 as it is, because it is a fraction. So we're going to take all the coefficients, including the one that's understood to be in front of the C8H18. We're going to multiply all of them to start with by 2. So 2 there. We're going to multiply this by 2 for 25. This by 2 for 16. And this by 2 for 18. So our coefficients are 2, 25, 16, and 18. You'll notice that some of these coefficients in combustion reactions can become very high. Now in this case, the hydrocarbon is on the product side. So we're going to start with the carbon. And we have 6 carbon, so on the reactant side we need to have 6 carbon. We have 12 hydrogens, so we need to have a total of 12 in front of the water, so we're going to put a 6. Now how many oxygens does that give us between the carbon dioxide and the water? Here we have 12 plus another 6. That gives us a total of 18. However, take a look at the C6H12O6, which you know is glucose. We cannot put anything in front of the glucose because we already have our carbon and hydrogen balanced. So what we want to do is we're going to take out those 6 that the glucose has, and we need now a total of 12 oxygens to make sure we have 18 oxygens on both sides. So here, we need to get a total of 12, so that coefficient is 6. You know this formula as the formula for the production of glucose, which is photosynthesis. The last one, we have 6 carbon, so let's put a 6 in front of the carbon dioxide. We have 6 hydrogen. So let's put a 3 in front of the water. Let's determine how many oxygen we have. There's a total of 12. Plus another 3 is 15 total oxygens on the product side. There's only one more place we can put a coefficient, and that's in front of the oxygen. And again, this one is going to be a fraction, just like the one two above. Now we cannot leave it as a 7.5, so we need to multiply every coefficient by 2, including the understood 1 that's in front of the C6H6. Multiply this by 2 to give us 15. Multiply this one by 2 to give us 12. And multiply this one by 2 to give us 6. And that is how you balance a combustion reaction.